Crypto Today.
I'm Richard. And I'm Andrew. So a brief overview of the project before we start into it. The existing goal of this project basically was to take cryptocurrency, as a function, as a unit of currency, and try to get it more integrated into ease of use for the user. So things that people may have heard of, like a nano ledger or other things like that, where I can, sign transactions, manage wallet, something like that. So.
All right, so the objective for our project is to create a device that is user-friendly and removes barrier entry to cryptocurrency. So we made a product that's simply plug and play, where you simply plug it in, set it up, and then you can start holding and generating cryptocurrency. And also this is done on the Dragonboard cortex-m to show off that we can implement cryptocurrency backend on an architecture. First and foremost, what is a cryptocurrency? For people who don't know, it is a decentralized digital form of currency that is not controlled by any government or institution, and all the transactions are visible on a public ledger known as the blockchain, which I'll get to in a bit. Cryptocurrencies work on what is known as a smart contract, where certain agreements are done between the buyer and the seller, and directly into the code, and both identities are now in this one ledger. Cryptocurrency networks are peer-to-peer rather than being on a centralized network. So this is to help with the integrity of the cryptocurrency, right? So if a centralized server goes down, the entire network goes down. And now the blockchain, how blockchain works is blocks of transactions are approved through cryptography, and these blocks are added to the chain on the ledger. So that's why it gets named blockchain. It's a chain of blocks of transactions on the ledger.
So there's a distinct difference between exchanges and wallets. Exchanges are when you purchase cryptocurrency from something like the way Wall Street works, but there's an advantage to storing your cryptocurrency privately. For example, exchanges are online and managed by entities such as Binance or Coinbase, and they're connected to the internet, which means other people can access them if they are they're smart enough to hack the system. The advantage of a wallet is if you store everything online, the only way for someone to access it would be to come to the hardware that you have the coin stored on. So we're using Smart Cash for our implementation, and the reason for this over, say, a more famous coin such as Bitcoin would be much lower transaction fees. Bitcoin, we would lose a lot of money just moving currency around. A lot faster, up to 10 times faster than Bitcoin in transaction times. And finally, we wanted to use a currency that rewards you for holding onto the currency, and you can hold a node if you have a VPS server that's running 24/7. Finally, our mentor wanted us to use an ARM device. For one, ARM devices pull less power and also create less heat when they're running. The device they gave us is the Dragonboard 410C, capable of running Android, Windows, and many other IoT softwares. And another advantage to this piece of hardware is that it can be developed on a virtual Linux platform and ported over to the device. So it helps with development. And finally, hardware-wise, there's a lot of opportunity for hardware expansion and development.
Okay, yeah, and this is just an example. So this would be running on a computer at my Linux. We use Debian environment, and you can basically take the image on your hard drive of your virtualized environment, and you can actually flash it to the board. So that's the used environment part. So our device operation is going to operate on 4 things here. So first is the crypto functions, and that's the core part of our device's goal. So this is going to be handling, storing our addresses where we keep our crypto coins. It's going to be handling our wallets, our private keys, our public addresses. And it's also going to enable us to send transactions to other people. So that's basically one of the core features of it. Another feature of Smart Cash, but also other crypto tokens in general, is you can host a node. A node, when the blockchain is a decentralized node platform, an individual can host one of these nodes, and it will traffic will run through it as you verify transactions on the network. The benefits of hosting a node, a coin such as Smart Cash, which is similar to Bitcoin, is that when traffic is running through your node, you'll typically get a payout, once per month of the currency designated. So in the Smart Cash's case, we get about 2,000 Smart Cash per month. about, I think, $200 on something like that. For the display, we have a serial display. You can see in the case right there. The serial display was so it could run headless. While the device has an HDMI port, we typically wouldn't want to run it on a full display because that's a lot of setup and use. This is something you would maybe set up a note on when you're rolling on in the background. You wouldn't want to set up a full computer system. Additionally, there'll be something called a crypto stock ticker, which I'll get into, and you can display wallet info, transaction info on this. This will all be in an enclosure that's 3D printed. Right now it's plugged in, but there's also space in that case for some batteries that will also need to. Okay, for the cryptographic functions, I use what's called the Electrum Smart Library. This is a branch of the popular Electrum wallet for Bitcoin. In the 10 weeks I had to do this project, obviously, writing our own cryptographic library ourselves wouldn't be feasible. From the mathematical functions to just sending transactions and raw transaction, it gets pretty lengthy. Luckily, there is this open source wallet library available. So this can be implemented on the ARM Linux on our device, and it allows us to do many standard cryptographic functions like send currency to other addresses, sign messages, store private keys and public addresses, as well as create transaction files, which is great for our use. So for the stock ticker, we had something, so as something maybe someone could potentially buy, right? So a lot of people aren't into the crypto space right now. So, a common consumer wouldn't know how much Bitcoins are worth or Litecoins or any other altcoin. So you would have something where it pulls data from the APIs or Coinbase from Binance, and you would have these conversion rates to fiat. So for instance, you have your wallet balance and however many smart cash you have, on the display it would show, smart cash would show your fiat value. So as an investor, you would know how much money I'm storing. Because I wouldn't know like 107 micro Bitcoins, but if I showed $1 on the screen of the device, that would resonate a lot more with consumers. So the way this works is it just calls the API from in a JSON format using the request library in Python, and that basically returns all the values from the website. Another key point is cold storage. So the idea of cold storage is having these transactions generated on my computer with what's called a public address. And this public address, it's like writing out a check, but not signing it. So then I take this file, this transaction file, transfer it to my USB or some other SD card storage, put it in the device. The device will have the corresponding signature for the check. Where, let's say my name's my check, my signature will be stored on there. But that device is offline. So if some hacker or some other entity wanted to access my main computer, and they got access to it, they couldn't actually steal any of my money because my private key is stored on the device. And whenever I wanted to sign my transaction, I'd physically plug it into the device, get it signed, bring it back, and then send it out. So in that way, it's more secure and you can't really hack anything that way. This is done basically by doing some back-end Linux stuff and the UW services, and as well as the systemd service. It calls the Electrum library from a bash script called Python.
So we opted to use a 25.4 LCD display for our product to display information for the cryptocurrency. It is powered through the 5-volt pin on the board, and since the I2C signals are 1.8 volts, we need to use a level shifter to step up the signal to 5 volts to display. So for our code, we're using the libmra and libupm libraries for Linux to help code using C++ and actually get the text from our cryptocurrency functions and print them to the display. Not sure you can see, probably can see, but it's actually currently displaying our wallet balance right now on the display.
Battery power is one of the stretch goals we have at the beginning of this program, and we created. As the raw diagram shows, we used to leave the portable battery in series to supply power to the device, and to accommodate the high voltage required by the program, we use a high efficiency switching regulator to boost and regulate the output voltage to 12 volts. The charger is programmed to provide a 1.3 amp charge current, and the charge duration is about 5 hours. Once the degeneration issue is solved, this duration can be reduced significantly. The balancer is to maintain equal voltage between the two battery cells to keep them safe to operate. And to speed up the charging and safely charge the batteries, we designed an auto switch that will disconnect the batteries from the device when the DC input is available. And this is the prototype of the power system. It is working as designed under normal conditions. And this is the PCB design of the circuit on the measurement that's developed by the 96Boards communities, especially for the memory board. And this is the schematic of the MOSFET switch. The PMOS over there, the M1, controls the on and standby power of about 128 kilowatts, and it is 87% efficient. So to achieve uninterrupted switching, we place a huge capacitor at the output of the switch, so to smooth out the transition between DC input and battery pack. It's a temporary convenient solution that's not on calculation and should be improved in the future for better performance.
So the case has gone through 3 iterations. This is the final prototype design, which includes space for the batteries, the driving board, the mezzanine for the driving board, and the display.
All right, so when the project was first proposed, it was originally to create a device that can function as a miner, wallet, and a node for as many cryptocurrencies as possible. Obviously, within the limited amount of time we had, we couldn't do that, and we could only implement it using smart cash. What's convenient about smart cash is the Electrum wallet is open source, so we can use that. And we also implemented the USB signing function for convenience. And then for the node and the miner, those are actually working together because we can host the node using the BPS service. And then with the smart reward system in smart cash, you can actually generate more currency like a miner just by holding the coin on the node. And then, of course, to make it a small, portable, user-friendly experience, we created a small enclosure for it, batteries to operate portably, and as well as a display to actually show the information, the stock ticker information and the wallet balance on the go.
And these are just some of the other boards. So in general, it's an ARM processor, but you can use any of these boards for your project. It's all running on ARM, similar to your phone or Android. All right, thank you.
So I missed what you said at the end. What was this
Yeah,
non-profit?
so these are this slide, right?
Yeah.
Yeah, so I'm saying we use specifically this board, but you could use, since it's running on an ARM processor on Debian Linux, you can take any ARM board that can run Linux itself and port it over. So we're not constrained to this one board. We can use any of these, profiles, and it can be adapted to many different, products.
Why did you use your specific board?
We use our specific board because that's our sponsor was from that company, so it made sense.
Okay.
So has someone invested or not?
No,
Not yet.
maybe a different one. I don't know what he's thinking.
Yeah.
It's a very volatile crypto space. So. Yeah.